Hey, I'm Steve, and I'm gonna make a tutorial on paper toss today because I was on the internet the other day and noticed a real lack considering the size of that game, at least what it used to be. It's gonna be very simple. It's just gonna be the paper ball, the background, um, the bin, of course, and it's just gonna have some wind going back and forth. We're gonna have to think about that wind as to where we're gonna throw the ball, paper ball. Um, Hopefully I can work out how to do it, and right now, just I think here, there should be the final thing that we're making today. So yeah, also I'm self-taught, so don't get upset if I don't follow the usual convention, just do things how you like it, but this is sort of how I just worked it all out. Alright, let's get into it. So the product name, just whatever you like, paper toss, paper throw, paper chuck. The team, that's my name, so you can put your name up there or whatever you want. The language, Swift, of course. It's lovely, it's beautiful. Not that I really know any others. Game technology, SpriteKit, devices, universal. We'll have a little section where you can change the variables. If you're on an iPad, it'll change the variables to this, so you can make it suit that a bit better. But we're just going to do the phone today. But I'll leave a nice little area for you to play with the iPad variables. And that's it. So next, create, and ooh, this is going to be rough. I think this is a laptop and it's running two screens and a lot of QuickTime players. So we'll see how this goes. All right, so we can probably just turn all that off here. We only want a portrait, otherwise we're gonna have problems. Actually, while we're doing that, we'll go into the info P list, supported interface orientations. We can just have the bottom home button. I think game scene. Let's just delete that, move that to trash, and make a new one. So just click here somewhere, Command N, new one, SpriteKit scene in iOS down the bottom, well, pretty low. Next, now we'll call it what it was, game scene, and that'll be in here. Oh, it actually won't go in there, but we'll fix that. There he is up here. Just drag him down there. Here we go. This thingy here. So this anchor point, see how that's on 0.5, that's right in the middle. That's what that cross is representing. If we just set that to 0, I don't know if anyone else does this. I like to work off the bottom left corner. I think people do. Anyway, so that's on 0. So now when we reference things, if we say self.frame.width, which will be that distance, divided by 2, which will be this distance now. SK scene, the class of this thing, it should be game scene, because game scene.swift over there on the, where is it? Over there, up here. That game scene.swift, that's going to be this thing. So we'll put game scene. Let's go into this here. We can get rid of those. They're ugly. This is ugly. Unless you need it, you can deal with that later. All but upside down. No, you just want dot portrait. We're going to have real problems today, just because poor little laptop is trying so hard. Portrait. Alright, up here we want aspect fill, but also what you want to do is set the scene, the size to the bounds of the screen, so otherwise it's not going to fill your whole screen on your phone. You can press play and see what happens if you like. I don't really want to. I've seen that too many times and it makes me cry. Self.view.bounds.size. Yeah. I think that is everything we're going to need in there. Sorry, I've got a little list of things that I want to cover over here, so if you see me looking over here, it's because I'm just double checking that I'm hitting everything. Okay, if we go into game scene now, there's a lot of crap in there. That's the default one. It's like a little touch thing that Apple have in there. Get rid of all of that and just put that. Before we get into here, why don't we go into the assets, and we're going to add these. We can get rid of that spaceship click and press delete. Down here, I'll add this in the description somehow. I don't know, this little folder here. What I've got here, I've just ripped these off Google Images, random background. It's quite nice, pictures of graphs. And yeah, great. I got a bin. This was one picture, and I just put it on Photoshop and chop the top off so that when the ball goes in the top, it goes behind this bit and in front of that bit, so it looks like it's going in the bin. It's not really. And this is the paper ball that I found, so we'll use that for a paper ball. I've just got this all off Google Images. If you do that, you should probably purchase stuff if you're going to release it. But this is just for demonstration. So here we're going to grab all those, drop them in, and that's that. So we have our little photos in here, pictures, whatever you want to call them. We're going to go to game scene, and we're going to have a physics. We're going to be using physics. I think they call it SKPhysics contact. SKPhysics contact delegate. So we're going to SKPhysics. We're going to add that in. Contact delegate, because we will be using physics, and we need to let the program know this. Or we need to let our little game scene know this. Also, I might just hit all these. I'm going to make a lot of those enums and structures up here, because I just find it easier to fiddle with things, all your variables and stuff up the top here. And if you need to alter things, you don't have to scroll through all your code and look for it. Well, it's just reference to these little things. It's like having your variables at the top, but this is different stuff. So I'm going to make one enum, and this is going to be game state. Also in this, I'm going to probably I'm going to do a lot of explaining things. So if I'll put little annotations that you can click to skip explanations if you know what I'm about to explain. But for some people that don't have much physics background and all that, they might need an explanation, and I'll probably go pretty in depth in that. But yeah, I'll give you little skip buttons to go through if you like. All right, so I'm going to make a couple of game states. One, we're only going to use one today because I won't put a menu on it. We'll just skip the menu, but we'll put it here just so you understand how you can use it. Just makes life easy. So we're going to have two cases. You can have more cases. You could have tutorial. If you're going to have a little tutorial playing, you can say, hey, the game state, it's in tutorial mode. It's running a tutorial on the screen, or it's on the settings page, or whatever. It comes in handy in the touches began and stuff like that. So you'll see this getting used a lot. We're going to make a static variable. We're going to call it current. And this, we'll just set it to playing, because that's what we're going to be going straight into. But you can, like, before we run each function, like the menu function, the playing function, you're going to set that thing to the right state. Now we're going to make a structure. This will make more sense later if you're not familiar with this. So we're going to have a structure, and it's going to be the physics category. So we're just going to call it PC, physics category. Put that here, physics category. And in here we're just going to have a lot of this is kind of gross, this stuff. Static let none. I'll just write one out and then explain a little what this exactly is. So it's 0, x, 1, arrow, or less than, and we're going to be this one can be 0. Okay, so actually, you know what, I'll write 2 so you guys can see, we can compare. Just get your copy paste skills going out here. There's going to be a lot of that. Okay, so this will be our ball. We won't actually have the paper ball's not going to be the one dealing with physics. That's just going to be like a skin on top of a sphere, right? So we have this every time we make an object that's going to be using physics. We need to allocate it a special number, because you got to think we're going to have sort of like the aesthetic side of a node, a sprite node, say a ball. It's just the picture, the size of the picture, all that stuff, and you'll see that in blocks. I'll point that out. And then under that, we're just going to have all the physics stuff about it. And what you're doing is essentially for this ball, we're making 2 layers, and the physics layer, the aesthetic one, sort of aesthetic side, you see that. The physics one, you're not going to really see this, so it's invisible, but it's the one that's actually making it realistic because it's reacting with things, whatever. So we need to allocate it a number. So every time whatever the item is that's allocated that number intercepts something, makes contact with something else, it's going to be like, hey, something happened. It made contact. Would do you want to do something with it? Well, we can sort of pick that out and say, if this happens, we want to do this or we want to do that. So we're probably gonna want a few things here. For the bin, we're gonna have like an invisible wall on the left of the bin, a wall on the right of the bin, and the base of the bin. We're gonna have like a start ground where the ball sits at the bottom of the screen, and then when we flick it, it comes up onto the bin, and then the bin's gonna be on another ground. So we're gonna want 2 grounds, like the starting ground and the ending ground, and the ball, the base, the walls. Okay. So let's get, like, I think we want that to go up to 6 then. 2, 3, 4, 5, 6. Okay, let's go through and change all these. So ball, we're going to have the left of the bin. We're going to have the right of the bin. We're going to have the base of the bin. And we're going to have the start ground. We can just call start ground SG. No doubt I trust that I will forget all of these when I need them. I'm good at forgetting all this. And then we need to give these all different numbers. So they're all an individual. And this, you can set this up as an enum, I think. It's just a bit, I think it's easy this way because you have to like add .raw value when you're referencing it because it's a uint32. To be honest, I'm not completely familiar with it. You can press option and click these things and give you a bit of an explanation, but this just gets rid of all the messiness. So all we have to do is say pc.none. We don't want it to have. I think you can also have, instead of none, all zeros, all zeros, which just means there's nothing, but I'd rather have my own one just because I'm weird. So then we're going to have another structure, and this will be when we touch the screen. We want to record that location that we've touched, like when we grab the ball, right? We touch the ball, ready to throw it. We want to record that spot, and we're going to drag and point towards where we want to throw it, and we're going to release then, and we want to save the end spot. So we'll make another structure, because I love my structures. And we're going to call this one T for touch. Right, so, whoop. What are you doing, Steve? Touch. I'll put maybe a little start and end touch points. Just a little bit of explanation next to these. The static var, bar. We're going to call this one start, and we're going to equal that to a CG point. And then we're going to have the same static var left to right bar. And we're going to call this one end. And this will also be a CG point. Because a CG point has 2 spots, and where you touch, that's like coordinates, you know. You got an X and you got a Y on your screen. So it's a CG point. You don't really need this. This is just another thing, so you don't really have to flick through all of your. This is a good one, I think, because we're going to struct C, and we'll call it C for just constants or something. So this, you can early on when you open up the app, you can set all these according to if you're on an iPhone or if you're on an iPad. You know, things are going to behave differently. So sorry, I was just dead set copying what I wrote above that. This is just constants. Yeah. So what we'll do in this one, we'll say a whole bunch of static variables again. Let's think, what are we going to have in here? We probably want to change our gravity. 9.8 is the normal gravity, negative 9.8, because it's a downward force, if you remember from physics classes. So we're gonna we'll call grav, and we'll just equal it to CG float for now, because we'll want to make this a bit lighter, because you're gonna throw a paper ball. You don't want to just go, you know, like you don't want to just fly down. You want it to sort of float down. It makes it look like it's got a bit of air resistance going with it, you know. Static variable. The Y velocity, I'll explain this a lot more when we get to it, because that's going to be one of those little points where I say, here's a button to skip all this if you don't want to hear it. We're going to make a Y velocity. So this is like a fixed, when we throw the ball, the Y component of the vector, so the total distance of height that it's going to make, or the total velocity that it's, you'll see it, but we don't want it to, if you drag a long drag and let go, we don't want the ball to just shoot through the roof. We don't want a hole in our roof, so we're going to make it constant. So every time you flick the ball, it's always going to go to the same height, whether it goes out here and back, or it goes out here and back, or it goes here, it's always going to come up to this same bar. So we're going to make a constant velocity. This, we'll do like air, how long, like a time, how long it's going to be in the air, so we'll call it air time. And this will be a time interval. Yeah. So you could do like all the maths and work out exactly how it is, or we can just guess it. And if I was going to release this, I'd probably do it mathematically, because then you change one thing and everything will adjust to it. But this is just going to be pretty short, and probably only be like 350 lines today. A lot of that is just copy paste of making stuff. Initial Y velocity, and then this will just be like time the ball is in the air, the amount of time that the ball will be in the air, and we're gonna fill that in with what we see when we flick it, how long it takes for it to go boom. Probably be like 2 seconds or something. So we got our physics contact earlier. Alright, we can probably start moving into it a bit. We will want some variables up the top. I like to space all this out a lot. I don't like working at the bottom of the screen here. Put a whole bunch of space here. Okay, so let's put a test mode sort of thing. So if it's test mode, this is sort of one I just started using recently when I discovered the what are they called? Forget it. Ternary operator. Yeah, that's a fun little one. That one. That's a cool little piece. So we're gonna make a variable, and we'll just call this like grids, because there's gonna be all these invisible grids, but when we're making it, we want to see these grids. So bar grids. We'll just say equal. So we want to see the grids, but we can turn that off when it's time to hide them, and then everything will adjust. I think we'll just go straight into all the nodes, the sprite nodes now. Put a nice little block. Okay, so variable, background, we'll call it BG. And we're going to equal that to an SK sprite node. Sprite node. And that's going to be image named. Hello Xcode, wake up. Image named string. I don't remember what we called it. Background probably. Let's have a quick look at what we got in here. BG image, bin back, bin face, paper ball image. I promise I will forget all of that. Okay, so we have BG image. We call that BG image. Call it whatever you like, as long as it matches. I'm gonna have a variable. Just call it B front, so bin front, and that'll equal an SK sprite node as well. And that'll be an image named bin front, I think it was. And we'll have var b back equals SK sprite node, and that's going to be an image named bin back, I think. paper ball. Yeah, we'll put that in for now. Paper p-ball. Let's call it p-ball. Equals SK sprite node. Image named paper ball, I guess. That's probably what I call it. Paper ball image. Paper ball image. If you see any red crosses where there should be one of these things, that means that that name there doesn't match what you got in your assets.xc assets. So just double check those. Now we're gonna want a bunch of shapes here. So we're gonna have a sphere, which will be the ball, and then we'll stick the p ball on top of that to make it look like it's the paper ball. But it's easy to just work with shapes, I think. I find anyway. So if we just put a ball in there, we're going to put a left wall for the bin, we're going to put a right wall for the bin, and we're going to put a base. We'll put an ending ground spot and a starting ground spot. Okay, so we're going to have a bunch of shapes. So variable ball can be equal to SK shape node, and we won't do anything to that yet. We'll do these and anything. Left wall, SK shape node. Oh, it's so hot here today. Must be like 40 degrees Celsius. Australia. 20 seasons in one day. It's only 4, but we make more somehow. SK shape node. Var base. The base of the bin would be an SK shape node. I feel like I should just be being a little bit smarter about this here. Just get the old copy paste out. End ground, and then we will want the start ground as well. Okay, these are all shapes. So the end ground, we'll put a little thing here. That's the bin will actually, technically it's floating, but this is what for the ball to land on. So the ground that the bin will sit on, the bin will sit on, so that when the paper ball misses the bin, it bounces along next to the bin at the same height as what the bin's sitting on. And the start ground is where the paper ball will start. Yay. Okay. What else are we gonna have? We want a we're just gonna put one label. So var wind label. And that can be equal to an SK label node. So we're just gonna have a wind label for today, and that's just gonna display what the wind is that's blowing. We won't have a fan though, so it's just gonna be, I don't know, wind blowing through the window over here or something, or this window here, it's blowing air in, and so our paper ball will get affected by that. Variable, I'm gonna put pi. You don't really need to, but every time you write pi, it has a tantrum. It says that you have to wrap it in CG float or whatever. So, oh, what have I done there? A variable to store the wind speed. Oops. Wind equals CG float. Yep. Alright, we might just leave those variables at that. If we need any more, we'll come back to that. I can't think of more. Yeah, I think that's good. So let's go into did move to view. And we need to set the contact delegate for the physics. So we'll do self.physicsworld.contactDelegate, and that equals self. That's an important little line there. That one. Yeah, don't forget that one. Also in here, this is probably where I'd say you can do this. You can set those constants at structure up there. Structure C. You can do all that here probably, or wherever you like, but it's a good idea to just do it straight away. So we can say if UI device dot current, I think, dot user interface idiom equals dot phone. So if we're on an iPhone, this is what we want our our constants to equal if we're on an iPhone. Else we're probably on an iPad. So we'll say, we don't want our gravity, we'll turn our gravity down a little because, yeah, then it makes it just looks like it's got some wind resistance. So instead of minus 9.8, that's the standard gravity on Earth, 9.81 something. We'll just bring it down to like 6, maybe. We can always play with it and just see how it goes. We'll set that other thing up here, y velocity, and essentially it's going to adjust the distance that it goes up. Really, it's not the distance, but it's gonna alter that. So I'm just gonna call it self.frame.height, and I'll divide that by 4, maybe. Yeah, let's see how it goes. And then this c.air time. This is how long the ball is going to be in the air. We really don't know yet. 2, we'll say 2, and then we can come back, and I'm sure we'll need to come back and adjust these, but we'll just see. So now that we've decided on a gravity, which you do this same stuff in here for your iPads or whatever, we might adjust the gravity from the usual 9.8. Gravity equals now gravity is a vector. This might be one of those times where I'm going to put a little annotation here and explain what a vector is, because there might be a lot of people that don't understand if people don't have that background. So yeah, I'll put a thing here. You can click through this if you want. I'm just going to explain a vector. You know what? I'll just drag this up. Hello. So we have this. A vector is got 2 components, an x and a y. So this is our x-axis, this is our y-axis up here, and a vector is like an arrow, really. It's just an arrow to here, right? So that's a vector, and a vector has this and this, and that x and that y corresponds to this point, and assuming you're going from the origin, or start point to end point of where you touch to let go, that becomes a vector. So this here would be like, you change in x, delta x, which is just a triangle in the x. So I think that's the usual convention. Pen doesn't work. So a vector is just two components, an x and a y, and they turn this into an arrow. Yeah. Anyway, so our vector is the change dx, delta x, the change in x is going to be 0, because that's what gravity is. It doesn't affect us sideways. And what did we set it to? -6. Okay, so our gravity is going to be -6, so that's down. If it was just 6, then we're going to fall up. So then we can probably, now that we've moved to the view, probably just jump straight into the game. So we'll say set up game, something. It's going to be a function. We're going to put that function right here. Set up game. Now that's going to be a big function. You know what? I might put all those other override functions in here, because that one's going to be big and ugly. It's going to be a lot of stuff to put in there. So if you just type in touches began, we'll use that, and touches ended, we'll also use that. We'll probably do these. These are going to be, there's only going to be a few lines really in here, so we might just do that before we get into that setup game, because that's going to be big and ugly. So for touches, we're going to let the location equal, if you've done any sort of games before or anything really, you'd understand what's going on here. It's just checking a set of touches. It's going to go through each touch and check. So if we're going to let the location equal for each touch location in self, because it's in the view. Then we're going to have, if this is where this game state thing comes in handy. If game state dot current equals dot playing, then we'll do all this. Else, otherwise you'll be in the menu, so you do like else if game state current equals menu, then you want these things to happen. We're just gonna we'll just put playing in here because that's all we're really dealing with. Because this is touches began, only as soon as the touch happens on the screen it takes it, not held, not let go when it's touched. So if the touch is inside the ball, then we want to record that location in that little T structure that we made back up there. So we're going to say if ball dot contains a CG point. What CG points do we know? Oh, location right there. We just made that one. If ball dot contains location, then we want our T touches dot start to equal location. Yeah. So that's I think that's like the end of that function. So then touches ended. So this is when we let go of the screen. I might actually just grab that, put that down here, and we'll just alter it a bit. So for touch and touches, let location equal that. If game state is playing, if ball, we can probably actually get rid of this line and just include it in the one above. Yeah, if game state dot current equals playing, then T end will equal location. So, but also if we touch the ball and let go of the ball, we don't want it to fire. We want it to, probably better off to just let it stay there. So if we let go of it, we don't want to do this stuff. So we're going to say ball dot contains location, but what we're going to do here is put not. So that pretty much says there, and the ball is not containing the location, so anywhere else on screen, then we want the end position to equal that location. And also we'll want to run our little function that's going to shoot the ball. So we'll make another function and we'll call it fire. I'm going to say function fire equals. Alright, so game state.current, when we move into the setup game, in case we were in menu, if you add menu later, you're going to want it to say, you're going to want to tell that little enum up the top that the game state.current equals dot playing. Let's give ourselves a whole bunch of space here, and we're going to say let bg scale equal. So if you're going to set the height first, then that'll be the second part of the scale. So we're going to set the height first of the background image, so that'll be the second part of the scale. So it's going to be the CG float of all of this. So the image before we've touched it, so in its normal size, so we'll say bg.frame dot width divided by bg.frame.height. Yeah. So that's going to give back, if we got a 700 width, if we've got a 700 width picture and 500 high, that's going to give us 1.4 as a scale. We'll say BG, which is going to be something like that. And then we're going to set the background size dot height, and that'll be equal to this self dot frame dot height, so the screen height. Now we're going to get the background dot size dot width, and that will be equal to background dot size dot height times that little magic scale. So that scale will then make our background the height that we want it at. Now this position, this is why we set that anchor point. So CG point of this. Okay, so center of this picture, we want it to be at self.frame.width. Self.frame.width divided by 2. And then the y component of it, we want it to be at self.frame.height, also divided by 2. We need to set the z position, which is like, z position's like layers. So we got 0, and then 1, 2, 3, 4, 5. The higher the number, the closer to you it's getting there. So we'll say bg.z position is going to be equal to, we'll say 0, because it should be the very back. It should be as far back as it gets. I think that's that. So then we just add it, self.addChild, bg. And why don't we run this and have a look? And we should just see the background. I'm hoping. There you go. Yeah, so you only see to the frames sort of, but that's okay. You can put whatever background you want in there. So we're gonna do the same thing, similar, right? And this is gonna be for the bin. We need a scale for it, so we're gonna say let bin scale, because we're gonna set the height of the bin first. The height comes second in the scale. So equals cg float, and this will be just the bin, whatever the bin. It doesn't matter, bin back or the bin face. Oh, sorry, bin back. Dot frame dot width divided by bin back. Ooh, what have I done there? Oh, I'm a mess. Divided by bin back. Dot frame dot height. So now we can add the back of the bin, probably be a good one to add. So we'll say bin back dot size the height of it. Bin back dot size dot height, and we're gonna equal that to self dot frame dot height divided by. Now let's have a look over at this picture here. I'd say there's about a third of the frame is down here somewhere. We probably want the height of that bin to be about a third of a third, so a ninth. So if we divide that by 9, we'll see how that looks. Bin back dot size dot width is going to be equal to b back. Oh, this is a horrible variable name to type. Dot size dot height times that bin scale. Yeah, handy little scale. The position of it, position, and then the z position. So bin back dot position will be equal to a CG point, because it's coordinates. It's got an x and a y, and the x we want it in the middle of the screen. So self dot frame dot width divided by 2. Yep. And the y component, what do you reckon we'll sit at about? I think a third will just be under that. So if we sit at about a third, self dot frame dot height divided by 3, and that'll probably be in a good spot. The z position, bin back dot z pos will be equal to the background dot z position plus 1. We just want it to sit just forward. That's like the second thirds back thing we're going to have today. And then self.addChild be back. Nice. While we're here, otherwise it'll look weird if we run that. We'll put the bin front in as well. So this is going to be a real easy one, but bin front dot size will equal the same as bin back dot size. Bin back dot size. Bin front dot position will equal the same as bin back dot pos, and b front dot z position will be equal to b back. Now this dot z position we're going to say +2 so that there's a space in between. Let's just say 3. Let's give 2 spaces in between the front of the bin and the back bin layer, so that when the paper ball goes, it goes between them. We're going to change its the paper ball's Z position when it's coming down to go between these two. So we'll leave that at +3. Let's build and run. That looks terrible because I did not self.add child. B front. There you go. Oh, horrible. There you go. I typed that wrong. Bin front. Apparently that's not what I called it. I called it bin face. We can just change that, or change whatever you like. Bin front. Run that again. Go back down here. You can either change that, or you can just change it in here to bin face. So what I've given you there is bin face in those pictures. Hooray, we have a bin. Okay, so next thing we're going to do is we're going to put some shapes in. We're going to put the start ground, which is like, it's like just here, just above, just like right there on that screen. It's not going to be far up at all. We're going to say start G. It's going to equal an SK shape node, a rectangle of CG size, and then we're going to say CG size. We'll say CG size is width and height. The width, we want it to be the width of the screen, so self.frame.width, and the height, we don't want it to be high, it's just a little bar. It's a line. We'll put 5. Doesn't really matter. Doesn't need to be big, but don't forget the brackets up here. Okay, now start ground, we'll need some color. Start G dot fill color will equal red. Red's fast. Start G dot stroke color equals dot clear, I guess. Start G dot position equals CG point, and this is going to be self dot frame dot width divided by 2 in the middle, and the height self dot frame dot height. We just want it like up a bit, maybe a 1/10 divided by 10. We'll need to give it a Z position to start ground. I'm just going to give it something stupid like 10. Start G dot Z position equals 10, and really far forward then. Now this is what I put that little grid thing on here for. So if we're going to use the ternary operator, I think it's called. Start G dot alpha is going to be equal. Now if you're not familiar with this, I'll just explain it as I'm doing it. Start G dot alpha, so this is the alpha. If it's 0, it's invisible. If it's 1, it's solid, like you can see it. So if it's in grid mode, we want to see these grids. Start G dot alpha equals grids, question mark. So is that true? If it's true, that means we want to see grids, which means the alpha equals 1. If it's not true, then we want it to equal 0. And it's that simple. It's genius. It's awesome. I love it. So then we can get into the physics. 0. Okay, so now we get into physics. So physics body, SKPhysics body. Yeah. Yeah. So we want to equal this to a rectangle of CG side, what we've already made. Start. So we're just going to equal the size of its physics body exactly to the aesthetic size of it. So dot frame dot size. Yeah. Yeah. So that should be good. We need to. You got to set quite a lot of things here to these things. This is why it gets so big. It doesn't. Well, it needs to be, but it looks a whole lot worse than it is. So the category bit mask, we've got to do this for every object, but we'll just get those copy paste skills going. The category bit mask, we've already made it, so what we can do is just type pc dot start ground. What do we call it? SG. There it is. Start ground. Okay, so that just allocates a number, a reference number when all the physics stuff's checking things. It knows that the start ground has that bit mask. Physics body, collision bit mask. I think that's another important one. So we want this start ground collision bit mask to equal. So these are things we want it to collide with. So we want the ball and the ground to collide, otherwise the ball's just going to fall through the ground. So pc.ball. We want the contact test physics dot contact test bit mask. So we're going to put pc num, because what the contact test does, actually if you press option and click it, it tells you a mask which defines the categories of bodies cause intersection notifications. So if we said ball there, then when the ball and the start ground hit each other, Xcode is told, it's notified, hey, these hit each other, do you want to do something about it? And we can be like, yeah, I want the ball to reset, or I don't know, add impulse, whatever you like. But we're not gonna have anything on that. Other two things that are important are gravity and if it's dynamic. So start G dot physics body dot affected by gravity. Straight up, there it is. No, true. False. It's a ground. It's a ground. We don't want the ground to fall. True. Start G dot physics body dot is dynamic. Now this means that we want it false. If it's not affected by gravity, it's going to sit there. But when the ball, say, fell down and hit it, because it's dynamic, it's going to have that Newton's second law, equal opposite reaction stuff. It's going to start floating off, you know. It's going to get force pushed on it, and it's going to be like, yeah, it's just going to float away forever. You can test that. Put it on true, see what happens. It'll be funny. There you go. There's our ground. You can put a table there if you want, or whatever you like, really. But we're just going to just have it sitting on the ground, really. Also, if you like add a shadow or something maybe to the bin, probably make it look a lot better. Even the ball, the shadow could look good. Not today. Not for us. We're keeping it simple. So we're going to copy paste all that, and we're going to make end ground. So we're going to make a second ground now. Just go through down the front here and boom, boom, boom. Change all these. And add end ground. Now we're just got to go through and make sure that these are right. We want the size of this. Alright, make this times 2. We want this twice as wide, because if we throw the ball from here and it comes out really wide and then starts hooking back in, and that ground that's going to go about here, if the ball comes under that, the ball will be little. It'll look little and it'll be back in the foreground. Just make it times 2. You can make it half and have a look what happens if the ball comes underneath that second floor. You'll see what I mean. But if it's on 1, I think it might just happen. You don't want that to happen. Just make it times 2. Fill color for this one, red. Yep. Stroke color clear, that's just the outline around it. You can leave it if you want it to just be white, doesn't matter. So this is going to be halfway across the screen, and the height, we put the bin on a third. So we want that to be a third, I think. But that'll be in the middle. I think if we put third, and then minus half the bin height, dot frame, dot height, divided by 2. Let me get rid of this thing. Yeah, that's nice. Ng dot physics body, we want it to be the same as the itself, not the start ground. Ng physics body category bit mask. This one will be Ng. What do we call it? EG. Yeah. Collision bit mask. We want it to collide with the ball. We will be altering what the ball collides with, but you just leave that there. We don't have to change that then, because we do eventually, when it comes back down, we want it to hit the ground and collide. Contact test bit mask. Nah, we don't need that. Affected by gravity, no. Dynamic, no. Moving on. We're going to... Oh, we'll run that. I'll just run that and you'll see it pop up. But we're going to go on to the left wall, I think. Left wall. That's the one. We'll go through. We're going to paste this in all. What's going on? Well, like that. There you go. We got a ground up there as well. Yeah, that's cool. We want the physics body to equal the left ground. This one, okay, so the left wall, we're gonna have that we're gonna fit that to the side of the bin. what have I done? Xcode's just had a little spaz attack. We'll just add that back in there. Var and G equals SK shape node, and he's back. Cool. Yeah, come on, there he is. Alright, so now left wall, we want to fit this to the side of the bin. We're just, the width of it, it's tiny, like 3, it doesn't matter how wide it is as long as it hits it, so the width is just super little. The height of it, let's start typing that and see what we come up with. We'll say B front frame dot height. Divide it by 2 maybe. No, because it's going to be about to make it like 1.6 maybe. Divide by 1.6. Might be a little bit bigger than, which we will kind of want. The red clear position, B front. Dot B front dot position dot X minus frame dot width divided by 2. But that's gonna bring it like out here. So we probably want to divide it by like 2.5 maybe. That'll bring it in a tiny bit. The Y, we want it to be position dot Y. Position dot Y. Poor computer. Poor computer. Alright, so the position of this here up front, really in front of everything. The left wall alpha grids is on, 1, off, 0. Left wall physics body, left wall, yep. We want to collide with the ball, category what's that? Contact test, nah, we don't want that. Affected by gravity, no. Alright, we'll run that. We might have to tilt it a bit, but we'll just run that and add that. I think left wall dot Z rotation, because we want to rotate this to fit the side of the bin a bit better. We'll have a look when it opens up. We're going to be sitting there. Let's start rotation. And we will, what's going on here? Well, yeah, okay, that shouldn't be in there. Done that. We already had that. It's just changed. I must have changed it when I accidentally clicked that thing earlier. I don't know. We'll just put 0 there for now, just to run it. But I think we're gonna go. We want to rotate it only very slightly, so it's like pi divided by something tiny. Yeah, so we got a nice line there for a boundary, but we want to rotate it just a fraction. So we'll do pi, which is 180 degrees, divided by 25. See how that looks. If this looks good, we can just copy that whole left wall for the right wall, which is nice. Oh, look at that. Yeah, I'd be happy with that. Yeah. Okay, so grab all of that. Left wall. Take it down here. Do the right wall now. So left wall, add left wall. Okay, right wall. So the shape of it will be the same. Fill color, yep. Position, no. B front position dot X plus, so we want to go to the right. Height of it can be in the same spot, 10, yep. Yep. PC, Oh look at that dot lbin. Sure, some people picked up on that. Right bin. So that's the bad thing about copying. Make sure you check all these things, otherwise you might notice weird things are happening. Collision bit mask. Yeah, we want it to hit the ball. Contact, none. Affected by gravity, no. Rotation, minus. We want it to go the other way. Minus pi divided by that. Add. Okay, see how that goes. Yeah, lovely. Look at that. Isn't that nice? So the base will be, we can just do another copy job for the base, and the base will be base. The base will just be width will be different. The height can just be the same. You know, it's just going to be a little bar across here. So when it lands in there, it doesn't fall out the bottom. And we'll probably just put a timer on resetting the ball today. But if you go further into it, it might be better to make a notification when the paper ball hits that base, and you can be like, time to reset the paper ball. Let's bring it out and put it back at the beginning and flick it again. So we'll pretend that we are going to do that, but we probably won't. But in case you want to alter that, so b front dot frame dot height. No, not at all. Height 5, 3, tiny. The width though, b face dot frame dot width divided by 2. I think could be good. We'll make it red, clear. Position, b front dot b front dot position dot x. And the y position, we'll just take off like a quarter minus b front dot frame dot height divided by 4. So we'll just take a quarter of the height of the bin off its midpoint. Position 10 alpha. Yes, please. For now. Look at me typing the wrong bloody thing. Physics base category. This is going to be different. This will be base. Collision bit mask. We want it to collide with the ball. Yeah. Contact. Okay. Well. Yeah. Let's just put ball. It's not going to do anything in this tutorial, but we'll put it there for good practice, because we would probably want to test when it hits the bottom of the bin on the inside. Affected by gravity, no. Rotation, no. That will probably be the base, I think, around that. Next thing we'll want is a label, the wind label. So we can say, we'll just put wind label, so it has something on it. Yeah, that'll work pretty good there. Could probably make it a bit lower, but that'll be fine. WinLabel.text. You can alter all these things if you like. You don't have to do the same, but it's all pretty similar stuff. So we're going to equal WinLabel.text, just equal it to wind equals 0. It'll change. WinLabel.position. We want it in the middle. And we'll just put it up above the door there or something. CD pointing, open bracket. CG float. So self.frame.width divided by 2. And the Y will just say like, what do you reckon's up here? 4/5 of the screen up. So self.frame.height times 4 on 5. We need a font size. I usually just go with like the adjusted according to the width of the screen. Font size will equals self.frame.width divided by 10. And that should probably give a nice sort of I think it'll say it about there. the label Z position. Yeah, wind label dot Z pos. We want to equal that to probably background dot Z pos +1. Should just be just in front, so it looks like it's on the wall. You can do whatever you like with it, but we're just going to put it there for now. And then we're going to add that in. Self dot add child wind label. Okay, I think that's going to be about the end of that function. Finally, there you go, a nice little wind label at the top. Okay, next we'll run the function that gets the wind. So once the scene's set up, we're going to find a new wind speed or whatever. We'll just call it set wind, and then we're going to set the ball to the position, because we're going to call the set ball every time we want to reset it. So we'll say set. Once the scene's set up, we can set the ball. Yeah, let's set the ball. We'll just put that function there so we can get rid of that error. Func. Put another one here. Func set ball. And when we reset the ball, we're going to want to make sure that the ball isn't still on screen. All right, now let's just take this base thing. We just work with that. We have our little. We don't have to think too hard. And we're going to set. This is going to be the ball. So ball. Try again. Circle of radius. Probably the bin divided by 2. Maybe the bin divided by 1.5. So let's say bin face or bin. What is it? Bin front. I keep forgetting what I call this thing. Bin front dot frame dot width. And if we divide it by 2, I think it'll be a little bit too small. 1 won't fit in the bin, so we'll go 1.5. Yeah. We'll use that ternary operator up here, because if we turn the alpha down and it's got a skin on it, the skin's going to disappear as well. So ball.fillColor, and we'll say, is it grids? If grids are on, we want it to equal, we'll make the ball blue. Else, we'll make it clear. It's simple, we'll just make that self.frame.width divided by 2. The Y will make that ground, that start G dot position dot Y, and then we need to plus half the ball, plus dot ball dot frame dot height divided by. Let's just do height, and then every time we put the ball on, it'll probably just drop from here and go dum, dum, dum. Yeah, it'll just drop there. The position of this thing can be 10, because this is just a shape, and we're not in the end we're not going to see this. But this is just a shape. So the rectangle, should be circle of radius CG float. We want it to be the same as that. And then we're going to set the category bit mask to ball. Collision bit mask. We want the ball to collide with the start ground at first, and that's about it. What do we call that? Physics dot start ground SG. We don't, when we throw it, we don't want him to collide with any of this stuff, because it'll just go bounce off. Before he comes back down, we'll make him collide. We'll make it possible for him to collide with all these. So contact test bit mask, the base. So that's where you'd probably say we'll check it. We're going to put true, affected by gravity, dynamic, true, so like it'll get thrown around a bit. We could put the skin in. I think we do, what do we call that? The paper ball skin. P-ball dot size. Let's equal that to ball dot size dot frame dot size, and then we can add that to the ball node. So if we say ball dot add child, people. I don't think it really needs anything else on it. I think that's good, but that just gave me a great idea. If we take this now, we can make the texture, give it a texture so it actually, the outline of its physics will actually be like the paper ball. So we're going to say texture, and we'll say SK texture. Texture, image named. What did we call it? Paper ball image, something like that. And the size of this will just be the same as the skin. So p ball dot size. Yeah, I think that could work well. I hope. So we're gonna set that. Now we've got to think that every time we throw the ball, it's gonna shrink. So before we set it, we want to make sure that the ball's scale is back to 1. So ball dot set scale, and we want to equal that to 1. We also want to make sure that there isn't any ball on there, because if we try and add it twice, it'll blow up. So p ball, the skin, sounds weird, the ball skin. remove it from parent, so it's out of here, and then the ball dot remove from parent. So I think that'll be all that happens for that. You can put little print functions just to show that all these functions are going off. We could probably do wind next, I guess. Wind will be a little one, I think. You could get more in detail with the wind. So for the wind, we wanna get a random number for the wind between, say, -5 and 5. So if it's -5, it's up here. It's going to go that way on the screen up there. If it's -5, it's going to blow the ball this way. And if it's positive, it's going to blow him that way. So we need to get a random number. So we'll say let rand R&D equal a CG float, open parentheses, and we'll get arc for random, which is that little random function with a upper bound of, because we want it to be between -5 and 5, we're going to say 10. So we're going to get a number between 0 and 10, and then we're going to -5 off that. So if the random number is 10, we're going to have 5. If the random number is 0, we're going to have -5. If the random number is 5, we're going to have 0. You know, it's going to take 5 off, so we end up with a number between -5 and 5, I think. Yeah, another thing you just have to do with this is wrap that in uint32, because that's what arc for random requires there, uint32. So once we get that, we can set the wind label dot text to equal wind. If you haven't ever seen this bit here, that just means you can put a variable inside and it'll convert it into the string. So put rand there, and that'll take whatever that number is and it'll make it a string. You can then add stuff here or put another one of those if you like, whatever you like, but we don't need that. So it's just gonna be that. So that'll up every time the wind updates. Another thing that might come in handy, well, obviously we've got to set the wind speed variable to ren. I think what we might need, because it's obviously not going to be perfect, the strength of the wind, because we're just going between 5 and -5, it's probably going to do absolutely nothing. We're going to make a multiplier, so we'll just say let multi equal just a CG float, and we can just edit this number to increase the speed, so times multi. So it's just going to amplify it sort of, so it actually does something. We can just put that on 20, so it'll be 20 times whatever our random number is. We can run that actually and just have a quick look, sneaky peek. Oh, look at that. There's our little ball. We can't fire it yet. It would be shooting this function, but there's nothing in that function, so it's doing nothing. But, you know, we got a -4 wind, so it's blowing that way a tiny bit. It's probably not strong at all because it's actually set to 4. Oh no, it'd be 4 times 20. Yeah, nice. Okay, so we need to get our vectors again. So we're going to make a vector out of the 2 points that we touched from here to here. It's like what I drew there, the arrow. We want to fire it in that direction, or we want to fire it in that direction. So what we're going to do is get the change in x. The y is constant because we don't want it to just fly through the roof. We're going to, no matter how far you stretch your vector, it's always only going to go a certain height, otherwise it'll just get ridiculous. So we'll say let x change. Now I did another game that used something similar to this, shooting things like with your finger, and I noticed that if you have a restricted y, then the vector that you think you're actually throwing it at is not what you're actually throwing it at, and it won't. Let me, this is here, click to skip or whatever here, but this is, I'm just going to quickly explain this. If you drag on your screen, this is our screen, if we drag from here to here and let go, and we have the change in y here, and we have the change in x here, what you think you're shooting is that direction. But if we've restricted this y value to, I don't know, 10, say you actually let go at 20, then the real vector that we will be shooting is the difference, because we will take the difference, the angle that we shoot it on, to there. So the real vector, if you think you're shooting it up here, you'd actually only be shooting it there because we've restricted that. So we need to account for this distance here on the x and reduce that. Now I've got the maths here for it. I'll put it in. If you want to try and examine it a bit more and understand it, I'll leave that up to you, but just take my word for it that it there's 2 lines after this x change line that'll alter that so it actually shoots in the direction that you're shooting. In the direction you think you're shooting, it'll actually shoot that way. So we're going to have change in x is going to be t.end.x. So final minus initial, if you remember anything from physics, if you've done physics. Otherwise, that's how you get the x component to your vector, or really you do final minus initial, and that will give you the change. No matter whether you got minuses, positives, it'll give you the change. So final minus initial, and that will be the x change. Now this is the part I've written down here somewhere. Yeah, okay, I've written this down, so you can either just copy it, or you can sit there and have a think about why this works. So I've taken the angle that you think that you're throwing it at, so that is a tan, arctan of x change. You can probably just leave this part out, and it'll just won't. This is just me being fussy so that it actually shoots where you think it's shooting, but it'll only shoot probably slightly off, really. But I think you'll probably notice the difference. A tan equals the end. So final minus t dot start dot y, parentheses, and then we convert that to degrees, close parentheses. Yeah, so that's the angle that we think we're shooting at, and then we can exchange. Let amended, yeah, we'll call it amended x. So the new x that we found out equal, this is a bit This is pretty gross, so you know you can leave it out if you like, but it's good. It's good to know. If you're not too great with maths, then just take this and run. And then we're going to times that by our velocity, that is c dot yvel. Now you can also you can reduce this again, so if you notice in paper toss, if you shoot it really far out to the side, I'm pretty sure if I thought I was shooting here and dragged that line, it's going to shoot a bit more upward. It's not going to let you shoot all the way out to the side. So you could like times that by 0.5, so play with that line, play with that little bit there, changing the 0.5 to getting rid of it so it actually shoots where you think it's shooting, or add that. I think it makes it a bit more user friendly. Then we'll just throw it then, I guess. Throw it. Yay. Oops. Throw it. Throw it. So we're going to say let the throwing vector equal cg vector, change in x, amended x, amended x, and change in y will be c dot y vel. So that's where we're going to throw it. Then we want to apply this on the ball. So ball dot physics body dot apply impulse. Apply impulse of throw vector. Yeah, throw vector. Actually, this would be cooler if we do this. Get rid of that. Apply impulse. Apply impulse. Yeah, at point. Yeah, this would be cool. So we're going to do at throw vector, and then we're going to do it at we're going to do it at the start point, not just at the middle of the ball, but wherever we touch. So if we touch on this side of the ball right here, and we launch it up, the force will be applied to that spot going upwards. So the ball's going to spin. Yeah, that'll be cool. But it's going to be applied to t dot start. Ooh, but there's wind. Yeah, the wind's doing nothing, but there you go. So if I click the center of the ball and I drag it up, I can drag it all up here and it's still only going to go to the height of the door there. I can throw it there, it's going to go to the height of the door. Yeah. I can do it on the edge of the ball and it should spin. Yeah. Oh, and you rolled off the screen. Bye. Okay. So we want to shrink the ball. So we can just say ball dot, when it's thrown, this will run. So ball dot run sk action dot scale I don't know what we want to scale it by. Probably like a third of its original size. The time interval, this is what we put down up earlier. Air time, the amount of time that's in the air. So we know how long it's got to shrink over. And then when it hits the ground, it'll go back to normal. We want to change its collision bit mask. Collision bit mask. So this will shrink now, but it won't reset. So it'll just get smaller and smaller and smaller. Boom. It looks like it looks right until it came back down. It'll go smaller again. And again. It's tiny. Alright. So we'll just do this off timer. So if we just let weight equal an SK action dot weight for duration time interval of c dot airtime, and we're just going to divide this by 2. So that's close enough to when it's like up high. It'll be a little bit before it's at its maximum height, which is alright. That's good. So we're going to wait until that time when it comes. I'll point on here when it comes up, and it's about here, and it's gonna fire away weight. Well, that'll finish, and then we're gonna then run this. Let change the collision. Collision will be equal to an SK action dot run block. We're gonna set the ball's new thing because we're inside this block. We have to reference self. So self dot ball dot physics body dot collision bit mask, and that's going to be equal to everything now. We want it to collide with the whole lot, so we're going to say pc dot start ground and pc dot end ground, so it'll land on that floor now. PC dot base, PC dot lbin, and PC dot rbin. I think that'll be it. Also, we want to, that's a good time to change its Z position so it looks like it's going behind that front of the bin there. Yeah, that'll be good there. So we'll say self dot ball dot Z position will be equal to, we'll just go with self dot background dot Z position plus 2, because that means that's on 1, that's on 0, that's on 1, that's on like 4 or something, so that plus 2 will be in between those two. And then at the end of all that, we can say run, self dot run action, sk action in a sequence, so dot sequence, and square bracket, and we want to wait, and then we want to change the collision, right? So then after that, we probably just want to look at resetting the ball. Wait and reset, but we'll have a look at that for now. So here you'll see it should, if I can account for wind, it should land in the bin. No, yeah, that airtime really needs to be reduced as well. It's cool, bud, isn't it? It's getting there, not far off. So wait and reset, we want to let wait for equal sk action dot wait for duration of 4 seconds. And then we're going to say let reset equal sk action dot run block. I don't think we set the wind in the ball function, so it's a good time to set the new wind. So we'll say self dot set wind, so we're collecting a new wind speed and displaying it, and then self dot set ball, so every 4 seconds that should go off, as long as I put this down here. Self dot run action sk action dot sequence, wait for 4 seconds, and then reset it all. Yay! Now run that. You might want to come back up here and change that end airtime. This here, you know what, let's just change that now, 1.5, and rerun it. Should be looking pretty paper tossy like now. There we go. Okay, so wind speed -2. Yeah, so this is pretty cool. You can adjust all of this stuff if you like. Make it a whole bunch stronger. I think we can probably turn off grids. So just change that grids to false now, and all those red lines will go away, and that blue ball. But the wind speed, that's probably still an issue. So if we here we got the multiplier that we had. So let's set that up to 50. Make it crazy. The wise words of Bob Ross. Let's go crazy. I don't think we have applied the wind yet, have we? We never applied the wind. That's why. Let's have a quick add the wind, Steve. So what we're gonna we forgot to we have the wind, we just aren't actually making it happen on the ball yet. So we'll just make another little wait time, let wind wait, and it'll have an SK action dot wait for duration, and this is how long we want to wait from when it's thrown to when the wind hits it. So probably just like a quarter of the airtime that it's, we don't want too long. Just say c.airtime divided by 4, I think, and then a quarter of the airtime it'll go start blowing. Let's push equal SK action dot apply impulse. You could apply a force like that. I just don't reckon it'd look so natural. Like it'll really travel. I think an impulse will look cool. So we need to add this wind impulse, and that's it says it wants a CG vector. Let's give it a CG vector then. Open parentheses, close. Change in X, we want it to be equal to wind, and change in Y, we want it to be 0 because wind doesn't affect the up and down. Well, in this case, it's not going to affect our up and down. The duration is just got to like push on it for a little bit. Just put 1 second. It's going to happen, and then we want to add this to the ball. So ball dot run sk action dot sequence of actions wind weight, and then push. And I think we might be done. So winds for, yeah, it's pretty horrible pictures to be honest, but whoa, the wind is strong today. Nope, this is some serious wind, guys. I don't know where that went. This is dramatic. Yeah, sit here all day, and yeah, you can, depends where you throw it, it'll add spin to it. Oh, that was a positive wind. Whoops. Oh, 2. Yeah, you got it. I'll have a look on my phone. Steve. Here we go. This is going to be a better way to watch it. This is on my phone now, so it's not going to be so laggy. I'm still nowhere near as good, but so you could probably be nice to turn the wind down. Oh no way! Would you look at that? You just adjust that that multiplier, this thing. Just adjust that, bring it down a bit, maybe. It's kind of funny, and you still can't get it. I'll just quit. So that's it for this video. If you liked it, give it a like. Got any comments, questions, requests to add on, put it in the comments below. I'll add that folder with the assets in it in the description. And thanks for watching.